I'm here to talk to you about carbohydrates today. Carbohydrates are a very special kind of thing. They're very, very important. You might know them as sugars. You can have simple or complex carbohydrates. You might know from any of your lessons on diet that simple carbohydrates, like sugar, aren't as healthy as complex carbohydrates. Carbohydrates have a definition which you must know and remember and understand the structural aspects of it. They are a polyhydroxyl aldehyde or ketone. Poly meaning many, hydroxyl meaning your OH groups, your alcohol group, and an aldehyde, which is a terminal double bonded O, or a ketone, which is a double bond O in the middle of two carbon chains. Remember, the letter R represents any carbon chain either side. So here we've got an R, and over here we've got an R dash, and that's because those two things are going to be two different carbon chains. Now, sugars themselves are generally about, should be a 5-chain or a 6-chain carbon arrangement. I think a lot of them are 6, some are 5, I need to check that out specifically. It's unimportant, as long as it fits the polyhydroxyl aldehyde or ketone definition, it is then a carbohydrate. I pulled this one from your textbook. This one's ribose. You can see here that this is an aldehyde because the double bond O is on the end. It's got 1, 2, 3, 4 hydroxyl groups. Therefore, it's polyhydroxyl. This one here, it's got 1, 2, 3, 4 hydroxyl groups. So again, this one's also polyhydroxyl, but it's got a double bonded O on one of the carbons in the middle of the chain, which makes this a ketone. So this is a polyhydroxyl aldehyde, this is a polyhydroxyl ketone, and both of them are carbohydrates as a result. Now, carbohydrates can join together in long chains. Remember, when you join an organic molecule together repeatedly in long chains, it creates sort of a polymer. So this is like a natural biopolymer. And if you've got a sugar by itself, like ribose or ribulose there, we call this a monosaccharide. So you're going to hear carbohydrate, you're going to hear sugar, you're going to hear saccharide. There's a bunch of different examples. So yeah, you're looking at a monosaccharide. In the event that you've got two sugars stuck together, you're going to get what we call a disaccharide. For example, sucrose, which is just sugar, like what goes in tea and coffee, that's a glucose monosaccharide and a fructose monosaccharide. And the glucose and the fructose are different in how their organic structure looks. I'll put a table online of common mono, di and polysaccharides. You'd think you'd have a trisaccharide for when you've got 3, but you've either got mono or di, 1s and 2s, and anything more than 2 is called a polysaccharide. A couple of very long examples of very long chain polysaccharides are starch, which is in plants. So I'll get a picture up of that. Cellulose, which is the cell wall of plants. So the starch is, when I say plants, that's where it stores its energy. Multiple glucose molecules stuck together. The cellulose forms the cell wall of the plants. That's where plants get their strength from. You see, like a tree don't have a skeleton, and that's because the cell walls in plants have strength due to the cellulose, whereas, animal cells don't have that cellulose outside. Energy is stored in animals like me and Eno here in a thing we call glycogen, which is another biopolymer made of many sugar units, and that's using glucose again as far as I'm aware. To deal with carbohydrates, you either have to, to join them together, it's a condensation reaction, so water's cut out and given out. To break them up, it's a hydrolysis reaction. Now if you look on page 180, figure 3.4.6 of your book, you'll see the hydrolysis and condensation reactions in process. You'd note that hydrolysis is not a process that's easy to do. It's often you need strong acid or strong base and lots of heat and lots of time. And of course that's not what happens in your tummy. You don't reflux stuff in your tummy. So we need, you want your belly scratched? There you go. We need proteins, which are like, what's the word for it? Enzymes, and they're amino acids. So here's the basic structure of the amino acid. You've got an acid group here, you've got a carbon in the middle, one of 20 separate things stuck to the middle of it, and then an amine. So it's an amino acid. And these fold in a very special way. They can be like hundreds of thousands of units long, often tens of thousands. And the way they fold gives a special biological site, and what it acts as is a biological catalyst. And so it's able to cleave the things like the complex carbohydrates and take it through that hydrolysis reaction, but without having to reflux. It can do it at room temperature, or at body temperature, and in neutral conditions. It doesn't need intense acids or intense bases. Polypeptides can, they've all got different names. They're the same thing though. Enzyme, polypeptide, protein. These things, they can catalyze biological reactions between 1,000 to 100,000 times faster, which is why we can eat a complex carbohydrate. The thing is though, it takes a lot more effort to break down long chain carbohydrates than it does to break down short chain ones. So, based on that fact, that's why when you eat the complex carbohydrates that you have to put more energy and time into breaking them down, is why they don't turn you into a giant fat ass. Whereas I love all the junk food with the simple carbohydrates and all the fats and the oils and the salt. Junk food, how good is it? Your favourite food is people food. You don't like dog food. You like people food. You like junk food too. So, yeah, that's carbohydrates. I've got a few other videos on them. And I'll be getting some examples of exam questions for you to look at. So, I guess thanks for watching, and I'll get a picture up of the chalkboards for you for later. You're a good girl. Thank you for your help. Good dog. Do you want to show everyone your trick? Come on. Up. No. On this way. Up. Up. Sit. Hotcha. No. Up. Come on. You sit. You gotta sit up. Yeah, that's it. Sit up. There. Hotcha. Good girl. Do it again. Hotcha. Good dog. One more time. Hotcha. Yeah, that's, you don't like to perform on command.